Welcome. Today we're going to look at how we can solve inequalities with addition and subtraction. Now, before we get into actually solving inequalities with variables, let's go ahead and review some inequalities that just have numbers. So starting off, first we need to decide, is this inequality true? 5 is greater than 2. If we think about that, yes, that is true. So we know that 5 is greater than 2. What happens if we add some numbers to both sides of the inequality? Well, let's try adding 4 to both sides. So if I add 4 to each side of the inequality, 5 plus 4 is 9, 2 plus 4 is 6, and if we bring this inequality sign down, is it true that 9 is greater than 6? Yeah, that's true. 9 is a bigger number. Now let's try adding negative 8 to both sides. So we can say plus negative 8 and plus negative 8. Well, if we are adding a negative, that's the same thing as just doing normal subtraction or subtracting a positive. So 5 and negative 8, that'll give us negative 3. We use the same inequality sign. And over here, 2 and negative 8 together, that will give us negative 6. So is negative 3 greater than negative 6? Well, if you're not sure, we can always think of a number line. If we have 0 over here, we have negative 1, negative 2, negative 3, and so on. Negative 3 is going to be much farther to the right than negative 6 is. So because negative 3 is farther to the right, that means negative 3 is greater than negative 6. So this is true. All right, let's look at another inequality. Negative 8 is less than 1. Is that true? Yes, that's true. Because any negative number is always going to be smaller than any positive number. Well, let's try doing some changes to this. So if we add 2 to both sides, negative 8 plus 2, that'll give us negative 6. We use the same equality sign. And 1 plus 2 will give us 3. So we'll end up with negative 6 is less than 3. Is that true? Well, if we think of a number line, this is a negative number, this is a positive number. Yes, a negative number is always smaller than a positive number. All right, then we go back to the same original inequality. This time we're adding negative 5 to both sides. So I'm adding negative 5. Well, negative 8 plus negative 5, those are all negatives. So altogether we have 13 negatives, or negative 13. We bring down the inequality sign. And over here, 1 plus negative 5 will end up with negative 4 as a result. Is negative 13 less than negative 4? If we think of a number line, yes. On a number line, if we have 0 over here, we'll have negative 4 somewhere to there, and negative 13 will be way farther to the left. So this is true. So this means, if we look at these different examples, whenever we add a number, the same number, to both sides of an inequality, the resulting inequality is true. So we had inequalities where we started out where they were true. We could add the same amount to both sides, and it still is a true inequality. Now, let's check and see if the same thing also applies for subtraction. So down here, we have the inequality 3 is less than 9. That's true. 3 is a smaller number than 9. So we can go ahead and subtract 8 on both sides. So we'll have minus 8 and minus 8. So on the left side, 3 minus 8 will give us negative 5. We bring down the inequality sign. And on the right side, 9 minus 8 is 1. So is it true that negative 5 is less than 1? Yeah, that's true. A negative number is always smaller than a positive number, so that is true. All right, next over here, we are subtracting negative 6 on both sides. So we're subtracting negative 6 and subtracting negative 6. Well, subtracting by a negative, that's the same thing as just adding a positive, and this is adding a positive. So really, this now becomes 3 plus 6. So 3 plus 6 is 9, and 9 plus 6, which will give us 15. So now, is it true that 9 is less than 15? Yeah, that's true. 9 is smaller than 15. All right, our last set of examples. We have the inequality negative 4 is less than 3. That's true. A negative number is smaller than a positive number. So we can go ahead and subtract 4 on both sides. So if we have minus 4 and minus 4, negative 4 minus 4 will give us negative 8. We bring down the inequality sign, and over here 3 minus 4 is going to give us negative 1. Well, is it true that negative 8 is less than negative 1? Yeah, that's true, because on a number line, negative 8 would be farther to the left, negative 1 would be closer to the right. So negative 1 is bigger than negative 8. And for our last example, we're subtracting 1 on both sides, so minus negative 1 and minus negative 1. Now again, subtracting by a negative is the same thing as adding the opposite, so adding positive 1, and also over here. So we can rewrite this. Now we have negative 4 plus 1, that will give us negative 3. And 3 plus 1 is 4. So is it true that negative 3 is less than 4? Yeah, that's true. A negative number is always smaller than a positive number. So if we look at all of these examples, we started out with an inequality that was true, and we subtracted the same amount to both sides of the inequality, and we always ended up with an inequality that was still true. That means whenever you subtract a number on both sides of an inequality, the resulting inequality is true. So this is helpful for us because now we know that we can use subtraction and addition on both sides of the inequality to help us solve inequalities. So on the back, we have a bunch of examples. On the left side, we have a review where it's a one-step equation because we have that equal sign there. Then we have 2 columns where it's a new version of the problem because instead of the equal sign, we now have an inequality sign. That is the only difference that we have going on here. So it asks us to solve each equation and inequality by using inverse operations. Clearly show the operation on both sides. So let's start with the equation. So over here, m plus 12 equals 10. Well, to get m by itself, to solve the equation, we need to get rid of the numbers on the same side. So to cancel out adding 12, we would instead subtract 12. So plus 12 minus 12 will cancel out. So we'll be left with just the variable m on that side of the equal sign. On the right side, 10 minus 12 will give us negative 2. So our final answer is m minus 2. Well, for our inequalities, we can use the same type of step. To get m by itself, we just have to subtract 12 from both sides of the inequality. So we'll still be left with m. We'll bring down the inequality sign. We want to make sure we keep it in the same orientation. We do not flip it around. And over here, 10 minus 12 will give us negative 2. And when the inequality sign is facing the other way, so when m plus 12 is less than 10, we can still solve that inequality using the same process, subtracting both sides by 12. So we'll be left with m is less than negative 2. So we can continue going through and solving all of these different equations and inequalities. So for this next one, g minus 9, we would cancel out that minus 9 by adding 9 to both sides. And that's the case whether there's an equal sign or an inequality sign. Either way, we'll always be left with g on one side. Here we have an equal sign. Here we have a greater than or equal sign. Here we have a less than or equal sign. And negative 2 plus 9, that will give us positive 7. Negative 2 plus 9 is 7. And negative 2 plus 9 is 7. For the next example, x plus 10.5 equals 23. Well, we need to get x by itself. So to get rid of this 10.5, now it is being added to x, so we will undo that by subtracting 10.5 from both sides. And we'll do that whether it's an equal sign or an inequality sign. So plus 10.5 minus 10.5 cancels out, so we're left just with x on one side. We'll have our equal sign or inequality sign brought down. And 23 minus 10.5, that'll leave us with 12.5. All right, next problem here. 8 plus d equals negative 10, or is greater than negative 10, or is less than or equal to negative 10. Well, right now 8 is being added to the variable d, so we can cancel that out by subtracting both sides by 8. So positive 8 and negative 8 will cancel out, so we're just left with the variable d. And we bring down the inequality sign from the original problem. Negative 10 minus 8 will be negative 18. So we'll get our resulting answers for each of the problems. Our next problem, k minus 6.2 equals 30, or is greater than or equal to 30, or is less than or equal to 30. Well, we need to get k by itself, so we have to get rid of this minus 6.2. To cancel out subtracting 6.2, we will add 6.2 to both sides of the inequality, or equal sign. So minus 6.2 plus 6.2 will cancel out. So we're just left with the variable k on one side of the equation, or inequality. On the other side, 30 plus 6.2 will be 36.2. So we'll have k equals 36.2. We'll have k is greater than or equal to 36.2. And for the last problem, we'll have k is less than or equal to 36.2. This process also works if there's fractions involved. So this is w minus 2/3 equals 11, is greater than 11, is less than 11. Well, to get w by itself, we need to get rid of this minus 2/3, so we can get rid of that by adding 2/3 to both sides of the inequality. So when we do that, minus 2/3 plus 2/3, minus 2/3 plus 2/3, minus 2/3 plus 2/3, those all cancel out. So we're left with w on one side of the equation, or inequality. On the other side, 11 plus 2/3, well, that'll just be 11 and 2/3. So when it comes to solving equations or inequalities that have either addition or subtraction happening between the variable and a number, you can always solve those by adding something to both sides of the equation or inequality, or subtracting something from both sides of the equation or inequality. Later on, we'll explore how we can solve inequalities using multiplication and division, but for right now, our only focus is on adding and subtracting.